This is 9.1b, and we're asked to use the improper integral definition of a Laplace transform to solve for the sine of 3t. This one's a little bit harder than 9.1a, but not too bad. So let's see what we can do with it. So this little note that Dr. Noren gave us here, this part is pretty much a Laplace transform. Yeah, so if you just add bounds from 0 to infinity, that's an infinity, and then you say that a equals negative s, and that b equals 3. Because keep in mind, definition of a Laplace transform says this. E to the negative st, and then some function of t. Okay, so that's what we have. We have e to the negative st once we evaluate it at these conditions, and then times some function of t. So we can use this to our advantage because we don't have to do any of the nasty integrating that is involved in that. So evaluating it there, let's go ahead and take care of our improper integral portion. So how we do that is we take the limit as t approaches infinity, and we rebound our integral from 0 to t to make it look like something that we're kind of allowed to do. And so then we have e to the negative st. Keep in mind this a is a negative s as I defined up there. We get e to the negative st sine 3t dt. Okay, so now that we've now that we've put our limit there, we can integrate. I use air quotes because we're already given the integration, which is really nice. So we can rewrite this as limit as t goes to infinity of our integral. So we have e to the negative st times negative s. Keep in mind, everywhere you see an a, just plug in a negative s, and everywhere you see a b, just plug in a 3. Just 3 cosine 3t, and then all divided by a squared plus b squared. Okay, so that was our integration, and that would have been the most horrible thing to integrate. I actually tried, and you get stuck in this this loop of integration by parts that you can't resolve. So it's really horrible. So let's be happy that we're given this. Again, we don't really care about our integrating constancy. So I'm sorry, and we have to evaluate this at 0 and t. So let's do that. We have our limit as t approaches infinity. Evaluated at t, it looks the exact same. So e to the negative st minus s sine 3t minus 3 cosine 3t, then over a squared plus b squared. And if I just noticed that I forgot to plug in a 3 there, but we can do that at the end because we've already stated what it stands for. So as long as we don't forget at the end, it'll be okay. So our t's look the same, and then when we evaluate it at 0, what is going to happen? So evaluating this at 0, we get our e to the negative 0t. So this term goes to 1. Nothing happens here, so we have a squared plus b squared. Oh, and the b. We forgot to substitute the b. That's okay. Like I said, we can wait till the end. And then what is going to happen to this cosine term? So what is the cosine of 0? So we have minus 3 and then times 1, because that is what we're interested in. That is a minus sign, not an equal. Okay. So here's what we have so far. Now let's apply our limit. So we have our, oh, I forgot, I almost wrote my limit again as I applied it. It's a big no-no, drop your limit once you apply it. So we have our e to the negative, I'm just gonna write e to the negative infinity, which we all know goes to 0. So if you don't mind, I'm not gonna write this giant term, but definitely do on your test. I just have limited room, and it would just be sloppy, but try not to do that on your test. I don't know if you could take points off for it, but you know, it's better to be thorough. So applying all these to infinity, obviously this term goes to 0, so we don't actually have any t terms to apply the limit to in the second one. So all we have is cos of sine 3t, and then equals, so we have our negative keep in mind this term goes to the bottom because it has a negative exponent. So I'm going to erase that. It also goes to 1. So all that's going to happen on our bottom is we're going to get a negative a squared plus b squared. Don't forget your parentheses. And then we're going to have a negative 3 on the top. So our negatives go away. And we can say that the Laplace transform of the sine of 3t equals 3. And then go ahead and apply this substitution. Negative s squared, which goes to a positive s squared. And then plus 9, which if you were to use a table of Laplace transforms, you should get this as well. So hopefully that made sense. This one was a little bit harder, but really just because there were so many terms going on. Let me know if you have any questions.